go. So today we are learning about inverse functions. Make sure once again your earbuds are out, your cell phone is put away. Don't write anything down unless I ask you to. Much of today will be building upon what you learned in Algebra 1, 2, and then we're going to add another component to it. So today, this is our goal. Our goal today is we're going to be provided with some type of a function. And let me make this up. Let's call this function g of x. We don't even know what g of x is. And now, in fact, for those of you that really like examples, let's make up an example. Let's say 3x minus 1. And I can take arbitrary numbers, which are random numbers. Let's use 1. And if I insert 1 into this function, turn to your partner in 3 seconds. What's the output for this function? If I insert 1, what is the output? To your partner in 3 seconds. 1, 2, 3. So what you're doing is you're saying 3 times 1 is 3, and 3 minus 1 is 2. The way we read that is, watch this please, the way we read that is for function g, 1 maps on to 2. Let's try another arbitrary number. If I wrote this down and I said 5, what does 5 map onto? Turn to your partner, go. You can just visually look up here. You don't have to write anything down on your paper right now. What does 5 map onto? To your partner, 3 seconds, go. 1, 2, 3. How do we get 14? Turn back to your partner. How do we get 14? Yeah, let's do one last one that's really easy. One last one. What does 0 map onto? You have 1 second, go. What does 0 map onto? 0 maps onto -1. So today, this is the goal. Today, this is the goal. The goal today is, how do we create an equation that goes directly opposite? So think of yourself as driving. If you've ever driven, this is driving forward. How do we reverse it and drive backwards and get the exact same things? So now we're going to have a function. We'll call it f of x. And guess what? When you plug in 2, guess what it's going to map onto? 1. And when I plug in, when I plug in 14, it maps onto 5. And when I plug in -1, it maps onto 0. Okay, so we're just going to reverse course. That's what we're going to learn to do today. And we're going to learn to prove that things are, in fact, inverses of one another in multiple ways. So today you're going to describe how the graphs of relation and its inverse are related, and we'll learn the procedural ways if you've forgotten how to do that. So let's make sense of this. This is a basic function. Again, you're writing nothing down. And we are able just to take random arbitrary numbers, we plug them in for x, and this is what we get. Okay, you have 15 seconds to turn to your partner. I understand it's hard to see that. So if you're watching this video, I know you can see y equals, but this says up here, by the way, if you could write that down on your paper, because we're going to use it a lot today, write down f of x equals 2x plus 4. If you're live with me in the classroom, the way it's centered on the board, you cannot see that well. This is y, or f of x equals 2x plus 4. Okay, before I move forward, turn to your partner and make sure what I'm circling right now, make sure that they understand what this means for this particular function. You have 15 seconds. Ready, get set, begin. Go. You should be talking to your assigned partner. Do you know what that means? I heard one of the groups up here say this perfectly. It just says, when I plug 2 into function f, guess what I get for a final answer? 8. When I plug in 3, what do I get for a final answer? 10. When I plug in 4 into function f, I get 12. This is the exact same thing. And by the way, this is another way to write it. The number that is right here, if I can go back and erase this, we may call this one of 3 things. So this value, 2 and 3 and 4, what do we call those? Anybody? Shout out a name. What can we call those? Okay, you definitely want to write this down if I'm not hearing words. Please write down input. Sometimes we use the word input. Other times we use the word x values, or we use the word domain. They all belong to the same group of values. You want to have those names down on your paper. Input, x values, domain, they all belong to the same thing. What we get as an answer, the 8, the 10, the 12, Those are referred to as the output values, the y values, or the range. You need to know that those are all grouped into the same terms. So when I said y equals 2x plus, let me go back here, 2x plus 4, y equals 2x plus 4, right? The domain was me plugging in 2. Or another word for domain, what could be something else? I could say the inputs. The input is 2. The corresponding output or range is 8. The input is 3. The output is 10. The input is 4. And the output is 12. I want you to be comfortable with those. Now today we're going to learn how do you reverse it backwards. How do we come up with this unique equation that takes all of these original range values and maps them directly to the corresponding original domains. It goes from range back to domain. And we're going to do that right now. So here's how we do this. You can see how it reverses course. You have learned how to do this. So the first thing we do, and don't write anything down, is we take the original function, and if we see an f of x, we change it to a y. You're only watching. Then we switch the x and y, like I've done so in this picture, and then we try to isolate the y, or get y by itself. So to get the y by itself in this equation, I first need to get rid of the positive 4. Opposite of adding 4 is subtracting 4. So I subtract 4 from both sides. X minus 4 will remain on the left-hand side, and 2x will remain on the right-hand side. To now isolate the y, opposite of multiplying by 2 is dividing by 2. The 2's cancel, and this is what I'm left with. This is what I'm left with. If you leave it like this, you're not wrong. This is not wrong. There is my problem. You may want to make it prettier and share the 2 with both the left and right, and that's how you get to this part. I shared it with the left and right, but they're equivalent forms. Okay, so we're going to try one right now. Let's make it very basic. Are you ready? So everybody on your paper, please write this down. F of x equals negative 3x plus 5. This is a review from Algebra 1-2, and procedurally all we're doing is we're coming up with the inverse. That would allow us to go reverse it from the domain to the range, and we go reverse and go range back to domain. First thing I'm going to do is I'm going to be lazy. Over the top of the f of x, I'm going to put a y. And now I'm going to switch the x and y. So x equals negative 3y plus 5. Okay, next up, I need to get y by itself. So how do I do that? Well, first on the side that contains the y, we need to get rid of whatever's being added or subtracted. X minus 5 equals negative 3y. Bless you. Now, opposite of multiplying by negative 3 is dividing by negative 3. Divide by negative 3. And so I could say the inverse of f of x is x minus 5 divided by negative 3. If you don't want to break it apart, I am okay with it looking like this. Okay, you have 10 seconds to check with your partner. I know based on last hour that about half the kids have forgotten these procedural steps and they just need a little bit of a refresher. Check with your partner and maybe explain to your partner what part confuses you. Ready, get set, and begin. Go. I know that if you're live with me in class, you can't see that very well. Please write this down. G of x equals 2/3 x minus 4. G of x equals 2/3 x minus 4. Step 1, go over the top of the g of x and make a y. And now I'm going to switch the x and the y. So x equals 2/3 y minus 4. To get y by itself, we first always get rid of whatever's being added or subtracted on the same side as the y. Plus 4, plus 4. 2/3 y equals x plus 4. There's different ways that we can move the 2/3 to the opposite side. The most common way you learn, probably starting in 8th grade or 9th grade, is to multiply by the reciprocal, which happens to be 3/2. 2 divided by 2 simplifies to 1. 3 divided by 3 simplifies to 1. And now I'm left with 3/2 times the quantity x plus 4 equals y. I don't want to leave it like this. I want to distribute that. 3 divided by 2 times x is simply 3 divided by 2x. And now, really common question I get from students is, when I take 3 divided by 2 and I take it times 4, do I take the 4 times both the 3 and the 2? What do? You only take the 4 times the top number. So 3 times 4 is 12. 2 times 1 is 2. And now I can simplify to get 3/2x plus 6. And this original problem was a g of x. So we're going to write it like this. I believe these two are inverses of one another. And we're going to prove, as we go through this lesson, how to show that. Turn back to your partner. Don't tell me, but be honest with your partner right now. A thumbs up, not based on your speed, can you keep up with me, but your understanding. A thumbs up, I'm feeling pretty good about this if speed's not a factor. Thumbs to the side or thumbs down. Show your partner, not me, where do you stand right now with this concept? Where do we stand? Okay, we are going to practice one that's at the Algebra 3-4 level. Please take out the paper that was provided to you by Luis this morning. And we are going to look at the first problem together. So we're going to start with an easier one. This is like a freshman level question. So find this problem right now. It says g of x equals negative 5x minus 10. It's the second problem on the top. So it's the top right-hand corner. With the help of your partner talking the entire time, I'm going to stop you in 1 minute. I want you to come up with a function that represents the inverse of g of x. Talking the entire time. You have 1 minute. Ready, get set, go. 1 minute. On paper, you're working through this. Go. Nicole and Jocelyn, would you walk around a little bit, making sure that they're understanding? Can somebody get the door for me? All right, so this is what I have. Now, could you take it a step further? You could, but I'm okay with you stopping at this point, okay? Can I have a thumbs up or thumbs down if you got to this point? Thumbs up, thumbs down. All right. So that's the freshman level problem. Now we're going to move on to a little more of the 3-4 level before we learn new stuff. Let's look at the next problem. So please look at the top left-hand corner. You're welcome to write right on your paper. This is the top left-hand corner. Step number 1, I'm going to switch the x and y. So this is really like a y. Let's switch the x and the y. Step number 2, let's isolate the y. So I'm going to subtract 15 over 2, subtract 15 over 2. These are added to the inverses. That means that they're directly opposite of one another. 5 over 2y equals x minus 15 over 2. Now, how do I remove the 5 over 2 so that the y is officially isolated? I'm going to multiply by the reciprocal. 2 over 5. Multiply by the reciprocal. Oops, so sorry. Now I'm going to put it right here and have to distribute backwards here since there's no additional room. 2/5 times x minus 15 over 2 equals y. When you distribute, we're multiplying. 2/5 times x is simply 2/5 x. 2 times 15 is 30, and 5 times 2 is 10. And so I end up with 2/5 x minus 3. This is the inverse. So how do I illustrate that as an inverse? Well, the original problem was f of x, and so I need to go back and write that this little exponent is going to be a -1. This tells me it's the inverse of this particular original function. Please go to your paper. Put the initials HW next to the bottom 2 boxes for homework. And we're going to take a picture of a look at this right now. So give me 1 second. All right, let's go back here. You ready? You're just watching. You are simply watching. When I was provided you with this particular function, and if I had to come up with a table of values, it would look like this. It could be any arbitrary value. So watch, I plug in -1, and I end up with 2. I plug in 0, I end up with 4. Plug in 1, I get 6. 2 goes to 8, and 3 goes to 10. This is what I have. Now, if I needed you to come up with values that belong to the inverse, turn to your partner, nothing on paper right now. What would be values that belong to the inverse? So here's the inverse. I don't know what it equals, but what are values that belong to it? You have 10 seconds with your partner. Ready, get set, and go. What does 2 belong to? What does 2 map onto for the inverse? Anybody know? -1. What does 4 map onto? 0, 6, 1, 8, 2, and 10, 3. I want you to come up with a statement. You're going to use the words inputs and outputs to describe the relationship between the function and its inverse. Right now with your partner, verbalize. I want you to describe how do the inputs and outputs compare between the function and its inverse. Ready? 10 seconds begin. So, the inputs of the original become the outputs. I need you to hear this. You can't just say the word opposite. Now that you're in Algebra 3-4, I know you understand it, but you can't just say the word opposite. You got to use the word inputs and outputs. You could say the inputs and the outputs are opposite with the function and its inverse, but what we're really looking for is this. The inputs of the original function become the output of the inverse. The output of the original functions become the input of the inverse. Or you may use the words instead of input and output, you may say domain and range. Now, what does this look like on a graph? Let's go through and do that right now. What does this look like on a graph? If I give you 2 functions and I ask you, like, how do I know if these 2 graphs here, which represent 2 different functions, how do I know if they're inverses of one another? Well, let's do this right now. Let's pull apart a few numbers. So I can see these go by 2s. So this is 12, 14, 16, 18, you can understand. So what is this ordered pair right here? This ordered pair is I move to the right 4 and I remain on the x-axis. This point is going to be I stay and I drop down 2. This point over here looks like I'm going to move to the left 4 and down 4. Can I have a thumbs up or down if you understand how I just was able to come up with those values? So those are the inputs and the outputs of the blue. Okay, how do I know if the function that's represented in red is actually an inverse of this based on this information? Go, turn to your partner. How do you know if these two graphs are actually functions that are inverses of one another? Okay, you ready? So 4, 0 belongs to the function blue. If the blue and the red are inverses, what do I need to do with the 4 and the 0? I need to switch them. So the input becomes the output and the output becomes the input. Let's check. Is 0, 4 there? 0, 4 is there. Okay, 0, negative 2 would become negative 2, 0 if I switch the inputs and the outputs. Is negative 2, 0 there? Yes. Now if I switch negative 4, it looks the exact same and it is there as well. So one way, looking at a graph, to check to see if the two particular graphs are inverses of one another is the inputs will become the outputs will become the inputs of the two functions. The next way is that if you graph them and you graph the line y equals x, those two functions would reflect directly across the line y equals x. You have to know this right now for a test or quiz. You have to be able to explain. Algebra 1, 2, it's more procedural. At this level, it's more explaining. Okay, here's the very last way that's brand new. So this is the Algebra 3, 4 piece of it. Please write down composition of functions. Please write down composition of functions. Give me 1 second. Again, please write down composition of functions. Okay, so I want to write down this low enough that you can see this. Let's make sure you can write that. Please write down this first function for me. Y equals 1/2 x plus 5. And the other one is going to be, so that's one function. The other function is y equals 2x minus 5. This is brand new, called composition of functions. It's another way to prove. So we're not proving graphically. Here's proving graphically. We talked about this. Now we're proving algebraically that these two are, in fact, inverses of one another. So here's what we do. We write down one of the two equations. It doesn't matter which one we start with first, because we have to do it twice. I'm going to start with the function on the left. I write down the function on the left, but whenever I get to an x value, I stop and I leave a space that has brackets or parentheses, whatever you prefer. There we go. I write down one of the two equations. It does not matter which one you start with. And when you get to the x value, always you leave that space. So leave a big enough space and leave parentheses or brackets in that spot. Now, what do you drop in there? You drop in there the equation, whatever y equals from the equation you have not touched. So in this space, I'm going to write down, oh, hold on here. Give me 1 second. This was supposed to have, hold on here. You know what happens? When you have messy handwriting, sometimes you forget a piece. So this should have been 5/2. Sorry about that. That should have been 5/2. All right, now back to this. So I'm going to go back to this piece right here, and I'm going to drop that into that space. So I'm going to write 2x minus 5. Okay, and now we're just going to work this out. So I'm going to take the 1/2 and I'm going to distribute. What's half of 2? Because when you use the word of, you're multiplying. When you distribute, you multiply. What's half of 2? 1. Now, when I distribute this 1/2 to the -5, we're going to multiply across. So 1 times -5 is -5, and 2 times 1 is 2. And a lot of times, naturally, kids get really scared whenever they see fractions. Notice how these are the exact same values, but one's positive and one's negative. They're additive inverses. When you combine them, you get 0. And we're left with y equals 1x. Box that in. We're half done with this problem. If you get y equals x or y equals 1x, they're equivalent, you know you're on track right now. On this point, we're on track to be able to prove these two equations are, in fact, inverse functions of one another. Now, we're going to do the exact same thing again. So I'm going to write down the other equation, y equals 2. I'm using this one. But wherever I see an x, I'm going to leave a big space, either with brackets or parentheses. Inside of that space, I'm going to come back to the equation I have not touched and write 1/2 x plus 5 over 2. And we're going to get started. Half of 2. Half of 2 is 1. So y equals 1x. When I take the 2 and I distribute it, I only take the 2 times the numerator. It's not 2 times 5 and then 2 times the 2 that's in the denominator. So 2 times 5 is 10. Don't forget about the 2 that was on the bottom. Minus 5. Well, I know 10 divided by 2 is simply 5. And the positive 5 and the negative 5, they're additive inverses, and there we go. It has to work both ways. Will it always, am I always looking for y equals x? I am. I'm always looking for y equals x. And I want to show you why. Look back here. What is the equation of this line? Y equals x. Okay? What happens if I come over here? I'm going to make this up. What happens if I do all the work and I get something like 1x plus 3? The first time I did, I haven't even done this part that I'm crossing out, and I get y equals 1x plus 3, and I check my work and I'm like, nope, I got y equals 1x plus 3. Then nope, we don't need to move on, because both times I need to get simply y equals 1x or y equals x in both situations, and in order to prove that the two functions are in fact inverses of one another. If I get anything else in that, then the answer is no. Okay, you ready? We are going to get started. I want you to flip your paper over. And we're going to start on the back side. You're going to follow along with me. So back side, you've taken this paper and you flip it to the back side. You've taken this paper and you've flipped it to the back side. If you don't have one of those papers, they were left right up front. Okay, here we go. Y equals 3/5. Okay, leave a big space. Plus 12 over 5. Every time, will it be a function? No. Eyes open. Eyes shut, you can stand up, okay? All right, here we go. In this space, I'm going to put the secondary function that I have not used. So I'm writing in 5/3 x minus 4. 5/3 x minus 4. What's next? What's next is we're going to distribute. So when you distribute, you multiply the top, so you multiply the bottom. So 3 times 5 is 15. 5 times 3 is 15. Now, I'm only going to multiply the 3 with the negative 4. So 3 times negative 4 is negative 12. And 5 times 1 is 5. When I simplify, I end up with 1x, and then these are directly opposite of one another. If they're directly opposite of one another, they cancel themselves out because they're additive inverses, and this is what I'm left with. Is this problem done? No. What do I still have to do? The other way. Yeah, I've got to reverse it the other way. So now I'm going to write down the second equation. So I'm writing down y equals 5/3, leave a big parenthesis, minus 4. And in that area, I'm going to write down the first equation, 3/5 x plus 12/5. All right, let's distribute. 5 times 3 is 15. 3 times 5 is 15, so I've done this part. Now I'm going to multiply straight across. 5 times 12 is 60. 3 times 5 is 15. I'm going to have you finalize this, and you have 20 seconds with your partner. Ready, get set, and go. positive 4 and negative 4. They're called additive inverses. They're directly opposite. They cancel out. So my question for you, are these two equations in fact inverses of one another? Yes, they are. Okay, here we go. I'm going to put this down right now. Okay, watch me. You are not writing this down. I want you to just keep your paper on the exact same side that you currently have it and find this question. Does everybody see which question I'm on right now? They're not numbered. It's just a little more than halfway down the back side of your paper. So these ordered pairs, these inputs and outputs belong to a particular function. Now I want you to find the inverse of this function. So what I want you to do is directly below what you see here on your paper, I want you to make this up. Take your cell phone, put it away, because if I see your cell phone on your lap, I will keep it till tomorrow. I leave at 10:55. You can have it after that point. Okay, you ready? Do me a favor right now, and I want you to come up with both the input and the output that belong to this for the inverse function. You have 10 seconds. Ready, get set, go. 10, 9, 8, 7. You're writing this down on your paper. This is already down. You're filling this in. 7, 6, 5, 4, 3, 2, and 1. These would be referred to as the input of the original. What do the input of the original become with the inverse? What do the inputs become? The outputs. So over here it's going to be -1, -2/3, 0, 1/2, and 3. And what do the outputs become? The outputs of the original become the input. So 1, 2, 4, 6, and 0. Okay, I'd like you to drop down to the very last question on the back side. You see 3 dots on that line. You have 10 seconds to write down the ordered pairs for those 3 dots. You're looking at the very last graph. It looks like this, and the graph looks something like this, something like that, and it has 3 dots. I know these aren't the exact dots, but it has 3 dots like this. Write down the ordered pairs for the dots that you see, and then turn to your partner and see, do they have the exact same ordered pairs that you put down? There's only 3 points. One of them occurs at 0, -4. It's hard to see, but another one is at 1, -1. And the last dot appears to be at 2, 2. Now, turning to your partner, put your pencil or pen down once you have that down. Turn to your partner. If these represent the original function, I want you to turn to your partner, nothing on paper, and I want you to verbalize what are 3 ordered pairs you'll find on the inverse function. Go. 3 ordered pairs. Okay, graph those. Go. You have 10 more seconds. Graph those. Graph the 3 new ordered pairs that should be on the inverse function. Using your ID, connect them. Okay, then I want you to graph the line y equals x. That means you're going to go 1, 1, 2, 2, 3, 3, and graph it out. You should be able to visually see in 2 ways that the 2 functions you've graphed are in fact inverses of one another visually. They should reflect across the line y equals x, and the input and output values should be flipped. Okay, please put a star. You have 2 more problems I want you to put a star on right now. I'm going to flip to those. Give me 1 second. All right, please put a star. It should be coming on in 1 second. It's coming back on. Waiting here. It's slow, but it's coming. Okay, you ready? Please put a star next to this problem, or put HW. This is your homework. Please put HW here for homework. So you have 2 homeworks here. Please flip this side if you have not put HW for these 2. Okay, those are the 4 problems I want you to get done before you leave class today. Begin.